Mohanlal. Good morning. The subject name is compiler design. In the previous lectures, we discussed about some of the concepts which are related to syntax directed translation and now code optimization. In the optimization, the important brief overview about what are the different principal sources of optimization. That is to be today we are going to learn the different types of optimization techniques that is to be followed while implementing this machine code in order to process the phases of all compiler design. One of the phase, it is important phase, that is code optimization phase, where it uses several techniques to translate the code that is previously available. That code that is different. Now we know that different phases like scale analyzer phase, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, and code generation. These are the 6 different phases of the compiler design process. So in this process, the phase that is intermediate code generation, whatever the code that is delivered by that phase can be taken as an input to the process of code optimization. And once again, this code optimization implements several techniques and send the output to the code generation phase. Now we are going to give the overview of this useful sources of optimization. Here, the transformation of a program is called a local, and it can be performed by looking only at statements in a basic block. Otherwise, it is called as global. Some of the statements we are going, previous lectures also we have seen what are the statements that are to be considered as a local and accessible to non-local access, and what are the things that is to be considered as global. Many transformations can be performed at both the local and global levels. Generally, the local performances are given as the first preference and then global performance. So these transformations called as function preserving transformations. These transformations are called as function preserving transformation. There are a number of ways in which a compiler can improve the program without changing the function whenever it computes. Some of the ways the compiler improved by implementing these techniques. What are the function preserving transformation techniques that are available? So, for example, common subexpression elimination is one of the important most, and second one is copy propagation. Third one is dead code elimination, and fourth one is constant folding. Function preserving common subexpression elimination, copy propagation, dead code elimination, constant folding. Now these are the common subexpression elimination. First is the one which starts with the expression. That is, what is the expression that is to be common? Expression E is called as common subexpression whenever that expression is expression that was previously computed. Whenever the expression that was previously computed and the values of the variables in this expression have not changed. Previous expression, whenever the recomputation takes place, that means in that expression, whenever the variables appear, that is not changed with the previous computation. The values are remain as that of previous. That doesn't change that value of that one for that variables in that expression. Then we are going to avoid such recomputation of the expression. Yes or not, if the variable exists in one of the expression and the same variable appears in the same expression again repeated in the next coming sequence of the instruction, then no need of the same computation for that is the same variable in the same expression. That type of instructions to be identified and verify whether that computation of the value is changed or not. Then whether that previously computed value doesn't change, Then we are going to verify that and eliminate that expression. Here in this example, for example, here we are going to see a block of statements that is defined in block 5. One block is defined, say block 5. This block 5 exists before. What are the statements that are available? So here the 4 star I, it is to be calculated, and then that is to be referenced. 4 star I, that is to be referenced as x equal to a of t6. Then 4 star I, once again it is to be calculated as some other assignment t7. Now we have to eliminate this computation, that is 4 star I and 4 star I, both the computations are same, but the assignment values are different. That means t6 holds value which is same as the value that is hold t7. Why? Because the computation is same for both the cases. So here 4 star I and 4 star j is assigned to t7 and t10. T8 is 4 star j, t10 is 4 star j. So here t8 and t10 also same. Now these expressions are to be recalculating twice. So we are going to find out and eliminate such. So using the t6 and t7. T6 instead of T7. So that's why here T6 is to be placed for these two cases, T6 and T7. So we are going to place an expression, this expression, that is T6 equal to 4 star I. And then X as T's. And now T8 and T10, these two are again same computation holds. So instead of repeating the same value, we are going to write this computation T8 as T 4 star j. And we have to eliminate what? T7. For in this case, we have eliminated T7. And in this case, we have eliminated what? T10. And then here T9 equal to A of T8, it is same as T, the expression holds. And A of T6 equal to T9. But here T7 we have eliminated. But instead of T7, the computation which is same as T7 is what? T6. So T6 is already available. So that's why you have to use in computation at the same, with different computation which holds the same value. So A of T6 equal to T9. Now A of 10 equal to X, but 10 we have removed, T10 is removed. Now here instead of T10 we are going to use T8. Why? Because it uses the same, it holds the same combination. What is the T8? 4 star j. So this 4 star j holds the same combination value for T10 also, T8 also. So instead of T10 we have removed T10. Why? Because it is recomputation. So instead of that, we are going to use T8 as a computation purpose, and we are going to recalculate this expression value which is same as the previous one. And the last statement go to B2 which is written as it is in the same as that of the in the case earlier cases what is there. So we have to optimize the code. In case of code optimization process, optimization of the code taken place by implementing common and subexpression elimination. This is one of the important technique where we have to verify the statements, instructions clearly, which of them are to be computed and which of them are recomputed, whether it is holding the same value or different value, if at all. If that expression value doesn't change with the eliminating of that expression values, then we are going to use this as the substitution purpose with the remaining values, and then we are after applying the optimization process, that is after implementing optimization, code optimization or sub-expression elimination. Code optimization process here there are different techniques. One of the techniques is common Subexpression elimination. Here we are going to implement common subexpression elimination. So this is the technique which is implemented in this example, where the calculations of the arithmetic expressions can be verified and recalculated cases, and immediately removing that expression values and then resubstituting with the other things, and then getting the modified source code, and this code is to be sent to the code generation phase. And another one is copy propagation. In this copy propagation, the format of the copy propagation, that is called as assignment of the format. That is what is called, suppose if f equal to z, then this type of statements are called as copy statements. That means it copies. Copy propagation is to be used G for F. That means where G is available, instead of G we are going to substitute that F. So that is the statement that is to be copied. Which statement? F equal to G. That means instead of one variable we are going to use another instead of. That means here F equal to G instead. That means we are copying this, we have to use G. Instead of F, we are going to write a G. That means we are going to copy the statement. So this is called as copy propagation. Usage of one variable instead of another. That means it is not comes under as an improvement, but some of the things are to be eliminated. For example, x equal to pi. Then a equal to x into x in r into r. Now you have to apply the optimization copy propagation. One of the optimization technique in this example, what we are getting, a equal to x. What here, x instead of x, we are going to use what, x equal to pi. This is the copy propagation. That means we are going to use a variable pi instead of x. That means here x in place of x we are going to write pi and r star r. So here this statement is called as copy propagation statement. This statement is called as copy propagation, where pi value is to be determined and with a list, and then a equal to pi star r star r. A equal to pi star r star r. And another one of the optimization technique is dead code elimination. Dead code elimination, here it is saying that a variable is live at a point in the program if the value can be used subsequently. Otherwise, it is dead at that point. A related idea is dead or useless code statement that computes value that never gets used. Here in some of the instructions, while developing the code, a variable may appear at any point of time, but if the variable appears at one instant and may be used for the several lines of code, after that it may not be used because of the program requirement. So such type of the cases you have to identify when the variable is to be appeared and when it is not appeared. And if that is not appeared so long time and the usage of that variable is not at all used by the remaining lines of the code, then it occupies some space. Maybe it is not required, verify whether it is required or not. Such cases we are going to, that means here the programmer is unlikely introduced a dead code. If at all, if you do not identify and eliminate that type of things, then it is unlikely to introduce the dead code intentionally. And this results to the previous transformations are also. It affects the remaining portions of the source code of the program, so that the code may not get efficiency of the extension of the execution. So it leads to different other things also. So that's why, for example, in this example, this I equal to 0, which is written as one statement, and we have taken one if statement, if the condition, and this I equal to 1, it is a true statement. The condition is true, and this condition here, is it satisfied with this anyone? So here, maybe we may use the case either true false, but here the already the first statement determines that the I value initialized with that corresponding notation. If this case occurs, then there is no chance of getting the result of the second one. Why? Because here we are saying that if condition, but here true we are specifying. Previously, what I value is already defined, initialized with some value, that is 0. But there is no chance of occurring this second statement execution nowhere. So that case, it is called as the code identified. It is called as dead code. That is, this block is never executes. It never gets execution. It is not a previous. Why? Because due to the availability of the previous statement, the next statement may not be executed. It doesn't goes to the second instruction. It skips off the if statement and goes to the remaining lines of the program. Why? Because I equal to 0, is it eliminated? Is it assigned? And no chance of getting if condition of it. So that is to be code which is to be identified as dead code, and that code is to be eliminated. This is called as dead code elimination process. And another important technique you in the copy, that is in the code optimization techniques, that is constant folding. That is the second. Another one is constant folding. Here we are going to reduce the code. Some of the code that is to be evolved, that means reducing at compile time, that the value of the expression is constant, and using the constant instead of is known as constant folding. That means here the expression is evaluated at particular point, and this at compile time reduce it to some value. Instead of that constant, we are going to represent that value. Then we can say that it is one of the advantage of this copy propagation is it returns the copy statement into a dead code. Here one example we have to consider, a equal to 3.1415. So here we are going to write a statement like this. Then instead of this statement, we can directly write 1.570. Why? Because the computation is to be done clearly instead of using some constant. That means instead of the value of the expression, a constant is to be applied for this. So that's why the expression computation 3.14157 by 2 is computation is to be written as 1.5. That means we have eliminated an operation called as division operation. That is the calculation another. And dead code elimination also removes the assignment to X, and transformations are also. For this, an example is to be considered in this one, X equal to T3. Now A of T2 equal to T5 and A of T4 equal to T3, go to it. So now here instead of X equal to T3, the first statement is to be written as A of T2, that is first. A of T4 equal to T3. But what about go to B to this same 3 statement has to be written as this, but we have eliminated X equal to T3. What X here? Here we have not used any that is X in the first statement, that is second statement, or we have not used X in the third statement, and we have not used in the fourth statement also. But the X value is to be assigned as T3. Anyhow, the T3 is assigned to some other array of index, that is A of T4. But here the computation Ax is not really required in the remaining statement. So here Ax is the computation which is available, but the remaining statements throughout the source code, all lines doesn't use this procedure. All use this procedure. So that's why we are going to improve the source code notations by implementing this type of expressions. This is one of the technique, that is constant fold, where the expressions are available, the computations are to be done, and simply replace with the constant. And here the expression is available and that is not used and eliminated at the end of. So assignment to x which is available but it is not used, that is eliminated. That is copy propagation. And one of the another technique, that is loop optimization. Loop optimization in the loops, especially inner loop, we are going to mention there will be a loop mechanism, inner loop, that is a loop can be placed inside another loop. There's so much amount of time that is to be carried out while running this program while that is implementing these loop structures. So what is the running time of a program that is to be improved, and if the number of instructions are to be loop inside the loop is decreased, automatically the time reduction takes place. So even if you increase the code outside the loop, increase the code outside the loop and you can decrease the code inside the loop, then the performance of the program is to be increased. So in order to do that task, we have to implement a loop optimization technique. Here the sum of the one is code of motion, induction variable elimination, reduction strength. These are the different techniques which are used for the loop optimization. Code motion, that means what is the code that is available inside the loop can be moved outside of the loop. A loop, inner loop, a structure is to be there, and outer loop which contains another structure. So this the inner loop structure, which carries out several instructions. Finding out the instructions which are not really required inside that inner loop, and that statements are to be picked out and placed outside, carry out, and then be placed outside of the loop, so that the execution of this inner loop, faster execution and time spent with that is very less compared to the previous executions. And we are going to increase this code outside rather than inside. Because of this, the code increases outside, not inside. So placing the code inside, more instructions can repeatedly task execution takes lot time. Another important one is induction variable elimination. So in induction variable elimination, we are going to apply this technique by eliminating variables from the inner loop. So some of the code we transferred. Similarly, if any variables appear, that is to be checked out and that is to be eliminated from the inner loop. That is called as induction variable elimination. Another one is strength reduction. In strength reduction, we are going to replace the expensive operation by a cheaper. That means expensive by a cheaper one means here the more difficult operations. So division or modulus, any other operations which are replaced by a small operation. Cheaper means small, like plus, minus. The consider into the hierarchy of various notations and implement removing of higher operations and placing out the smaller operation. So here the strength that is division, that is to be replaced and placed with the plus or minus, so that it that is one of the one. Another one is multiplication addition. that is plus multiplication star plus minus. So here multiplication you can apply with the lower operation. Replace the multiplication with the lower. Similarly, division, replace that one and substitute with the other still lower. You have to find any chances of reducing that operation. We are going to replace and provide that operation so that execution of the expression takes very less time. So that is called as process of strength reduction and code motion. So first we are going to taken with a brief definition. Now each with can take with an example also. Here the code motion is to be used with the purpose of reducing the code, where the lot of code which is evolved inside that one that is to be carried out and placed outside of it. Means amount of the time that is spent, what is the inside the loop can be reduced. That is the main motto of the code motion. It decreases the code that is available inside the loop. Whatever the code that is available, say for example 10 instructions or 20 instructions which are available inside the loop, inner loop. So that is to be reduced with either 5 or 10. Then that is inner loop. So we have to as much, not only of requirement, as per the requirement necessary which is required, and that is to be considered and then put in. So here the transformation takes an expression which yields the same result independent of the times of the loop which are executed. That is called as loop invariant computation, and places the expression before the loop. Note that notion before the loop assumes the existence of entry for the loop. Before the loop assumes the existence of an entry for the loop. For example, here the evaluation of the statement limit minus 2. It is a loop invariant computation for the while statement. Here in the while statement, it is clearly written while I less than or equal to limit minus 2. So even if you change the code with while I less than t, even if you change the code while I less than t, so while is same, I less than same, but instead of limit minus 2, we are going to assign t. So that is the statement which you are going to be clearly written, assignment t equal to, and that t is substituted with while loop. So no need of change or result or expression may not affect if the computation is to be carried out with this while loop and previous one, but the code that is to be available in this can be moved outside by placing an equivalent statement of the code, that is t equal to limit minus. So this is the code which is to be available. Instead of that, we are going to write this while statement while I less than. So the processing is same as that of that one. Hence, same result takes place, and it does not change with either limit variable or I variable or any other means of the statement instruction. Simply, we are going to move some code from loop which is there inside, can be placed, trying to place outside, so that the expression which is computing before that same result as that of the independent of the number of times that is executed with while loop, and this computation is called as loop invariant computation, and this is called as loop invariant. So what is the code that is to be available? That is placed before the loop. So we are going to write while we are going to write the statement, that is while I less than or equal to t. But here what is assumption? T equal to limit minus 2. So this to be carried out the task while applying. So instead of this statement, we are going to write this computation while I less than or equal to limit minus 2. So this is the active task while computation each time the performance. So that is to be increased. If you replace this while loop with these two lines, then the computation of the performance is. Second one is to be considered. So these are the techniques of this loop optimization. One is code motion, induction variable elimination, and strength reduction. So induction variable elimination is simply we are going to replace the code which is available. That is, code means here what are the variables that are available. So here, for example, B1 is one block, B2, B3, B4, B5, B6. There are several blocks which are available. So out of these blocks, we have to verify some of the variables which are not required really inside the loop for that block of statements. So that is to be identified. So I equal to m minus 1, which is available, j equal to n, t equal to v equal to. So this block is to be identified as same, and b2 is the same, and b3, if we consider j equal to j minus 1, t4 equal to. So here we have replaced this 4 star j with the computation here 4 star j, which is to be written as a separate for T4, 4 star j, T4. That is to be this the statement which is to be placed outside of that is not required the computation inside the loop. So that's why that is moved outside. And here T5 equal to A of T4, and if statement as it is. But here we are going to write the same if condition, block B5, B6, these are all same. Only the change requirement with this one is T4 is to be moved, this statement moved outside of that loop and then placed as before the loop starting. And because of this, we are going to make 4 star j, 4 star j, T4 equal to 4 star j. So that is the j equal to j minus 1, 4 star D4, T4 equal to 4 star j, and T5 equal to A of T4. Now we have to keep that is T4 equal to T4. What is T4? 4 star j. So T4 minus 4. T4 minus 4. We are going to use that computation. So based on that, what is this one? We have to verify what that computation is there. So T4 completely. T4 is used in B3 and J in B4. We cannot get rid of either J or T4 completely. So that's why T4 is used in B3 and J in B4. T4 in B3 and J in T4. J in B4. So here we are going to use J, that is T5 greater than B and J, I less than equal. So for that reason, we are going to use this type of the computation as the number. Another one is strength reduction. So we know that higher computation operations which are available, that is to be replaced with the smaller computation operation, that is lesser. So higher computation operations are there, that is x power 2. So here the power computation which takes a longer time. So instead of that, we are going to write a lower computation value, that is star. This is a multiplication. So this is the example where we can carry out the task replacement of this small. So here power operation which takes and sometimes shift operations and division operations, floating point division. So such type of options we are going to replace any possibility of applying that one. Then we have to use this one, strength reduction. So these are the various techniques which are available in the principal sources of the computation values. Now we'll move to the next topic.
Like, share and subscribe. Hit the bell icon for more updates.